Hello and welcome. Today we're going to dive into one of the most remarkable dates in the history of mathematics, a single day that, across the centuries, just happened to produce some of the world's most brilliant minds.
April 1st. Yeah, we all think of April Fools, right? But in the world of math, it's no joke. Turns out, it's a day of pure genius. Let's find out why. Get this. Across 3 different centuries, this one single date gave us 3 brilliant thinkers who completely changed how we see the world. Our journey starts way back in the 18th century. So, our first story, it doesn't kick off with some complicated equation. Nope. It starts with a question about the massive structures that shape our modern skylines. I mean, how can something so incredibly massive and rigid also be flexible? It seems impossible, right? But the secret? Well, it all lies in understanding the hidden patterns of vibration. And a key to this whole puzzle? It lies with a truly remarkable individual, born on, you guessed it, April 1st, 1776, Sophie Germain. And get this, she was a self-taught mathematician who pursued knowledge in fields that society at the time had pretty much declared off-limits for women.
Germain was just captivated by how sand could form these beautiful, complex patterns on vibrating metal plates. She just knew that behind all that visual magic, there had to be a hidden mathematical order. Her pioneering work, her efforts to describe these elastic surfaces, it laid the very foundation for the modern theory of elasticity, the science that keeps our bridges and buildings standing tall.
Her legacy is, well, it's all around us. Every single time you see a skyscraper sway safely in the wind, you're witnessing the real-world impact of her brilliant curiosity. Okay, we're still on April 1st, but now we're going to jump forward 25 years. We're in a completely different country, looking at an entirely different kind of puzzle. Our next story takes us away from the world of physics and into the pure beauty of geometry. Imagine taking one of the most famous equations in history, the Pythagorean Theorem, and proving it's true just by cutting and rearranging shapes, like a puzzle. No algebra, no calculations. Could you do it? Well, one person who did exactly that was Henry Perigal, born on April 1st, 1801. He was an amateur mathematician who just had this incredible passion for seeing the world through the lens of geometry. Perigal had this beautiful obsession. He created what's known as a dissection proof. He showed that you can take the squares on the 2 shorter sides of a right triangle, literally slice them up, and then reassemble them to perfectly form the square on the longest side. It's visual, it's elegant, and it's just undeniable. In fact, he was so proud of this proof that he actually had the diagram engraved right on his tombstone. He showed that a deep mathematical truth could be understood not just through numbers, but through sight and touch. It was an absolute masterpiece of creative thinking. One date. So many incredible stories. But we're not done yet. Let's keep going. We're still on April 1st, but now we leap forward more than a century into a brand new mathematical quest. This final story, it's all about the search for something truly unique. No, really, think about it. It's one thing to discover a neat mathematical pattern, but it's another thing entirely to prove that no other pattern like it exists anywhere in the infinite universe of numbers. I mean, how would you even begin to do that? This absolutely monumental task was taken on by Sheila Edmonds, born on April 1st, 1916. She was a mathematician who was just completely fascinated by the endless, intricate world of infinite series. So Edmonds tackled this beautiful formula that had been known for over 1,000 years, that the sum of a series of cubed numbers equals the square of the sum of those same numbers. It's an elegant identity, but she asked a really profound question. Is it unique? Could other powers have a similar kind of relationship? Well, in 1957, she proved definitively that the answer is no. This pattern stands completely alone. You see, her work wasn't just about finding a pattern. It was about proving its absolute uniqueness, turning a known fact into a confirmed mathematical treasure. Okay, so we've got a woman who studied vibrations, a man who cut up squares, and another woman who proved a formula was unique. What's the thread that ties them all together? Well, every single person we met today, from different centuries, from different countries, they all ask the same fundamental question. What is the pattern hiding inside all the chaos? Germain found the pattern in elasticity. Perigal revealed the hidden pattern in geometry. and Edmonds confirmed the unique pattern in a series of numbers. And just because they asked that question, our world is richer, and we understand it a little bit better. It makes you wonder, doesn't it? What patterns are right in front of us, right now, just waiting for